going to be exploring electricity and some of its property. But to start, I have something to show you. Raise your hand if you've seen this before. These are called fortune clover. We are going to come around and give each pair one of these so you can investigate what happened when you put it in your hands. Before we do so, each person in your pair will get a chance to hold the fortune clover, but you have to make sure you are taking turn. Okay, now that everybody get one, I want the first person in your pair to put the fortune clover in your hand. I'll give you 20 seconds to do so. Okay. Now put it on the table so it can go flat again. And when it is flat, I want the other person to hold the fortune clover. I'll give you 20 seconds to do this. We are now going to come around and pick up the fortune clover. But as we do so, I want you to talk to your partner about what's happening and what causing it to curl up like it did. Alright, now all the fortune clover have been collected. I want you to tell me what happened when you put the fortune clover in your hand.
It curled up.
Right, it curled up. Why did it do that in your hand and not on the table?
Because our hands are hot and the table is not.
That's right. The reason why the fortune clover curled up in your hands is because the heat in your hands made it move. Your hands were given off a type of energy called heat energy, and today we will be exploring how heat energy and electricity are related. And by the end of the lesson today, you should be able to answer the question of the day, which is, how does the flow of electricity in a system produce heat energy?
Alright, so to start off, I'm going to pass out your job cards for the lesson today. Make sure that you have a different job card than the one that you did last time, and make sure that everybody in your group understands what your job roles are. So what we just saw was a good example of heat energy causing things to move. We are going to be talking about how heat energy relates to electricity. So where have you seen electricity being used?
To power my computer, to power my radio.
Okay, good. So we see electricity in our daily lives, from the electricity in our phones to the electricity powering the lights right now so that you can see. But what is electricity and how does it work? So before we talk about that, we're going to be passing out a vocabulary worksheet. And as we pass out the vocabulary worksheet, every time we go over a new vocabulary word, as a class, I want you to fill in the word for the appropriate definition on the worksheet. So our worksheet looks like this. Okay? And I'm going to be coming around and passing these out. Alright, so let's start off talking about electricity by talking about atoms. So an atom is made up of positively charged particles called protons and negatively charged particles called electrons. So my partner is going to be drawing this up on the board so we can get a visual of what atom looks like. So the electricity that is used to power different things is called electrical current. So electricity is the flow of electrons passing from atom to atom in a system. So this is our first definition. So everybody say electricity with me. Electricity. Yeah, good. So find electricity on your vocabulary worksheet and fill in the word in the correct space. Alright. So in order to get a better idea of what electricity is, we are going to be acting out being a circuit as a class in what we call circuit theater. So let me have everybody stand up and form a circle in the room. And I need one person to act as a light bulb while everybody is going to act as our wires in our circuit. Alright, so my partner and I are going to act as the batteries in our circuit. We are going to be using these washers in order to represent the electrons flowing through our circuit. The battery will initially start off with a bunch of these washers, and we'll be handing them through the circuit to represent the electricity flowing from the battery. When the circuit is complete, the electrons will flow through the wires from atom to atom. You will demonstrate this by using only one hand to pass off the washer to the next person. You will only have one washer at a time, so as you get one, then you have to pass it to the next person before you can get your next one. But you need to make sure that you keep up with the flow so that it doesn't stop. And you can also not drop your washer because these represent our electrons. In real life, atoms don't just randomly drop off their electrons. So you have to reenact being an atom. Alright, so what do you expect will happen when the washer's in my hand? What do you expect to happen with the washers in my hand once our circuit is completed?
They will be sent through the wires and end up back in the battery.
And as the electrons pass through the light bulb, what do you think will happen?
The light bulbs will turn on.
Right. So as electrons pass through the completed circuit, they will make the light bulb work. Alright, so remember, electricity is the flow of electrons from atom to atom. So will the atoms in the wire be moving through the wire like the electrons, or will they stay in place?
They will stay in place.
Good job. In a completed circuit, electrons will be moving from atom to atom, but the atoms will stay in the same general area the whole time. So now, it is time to demonstrate the flow of electricity through our circuit. So, if everybody, except for our light bulb person that we'll pick here in a second, represents the wires of our circuit, how should y'all be standing so as to complete a circuit?
We should all be standing in a circle next to each other with two of us on either side of the battery. We should also have our feet touching so the circuit is complete.
Good job. So yeah, one person needs to be on one side of the battery and another person needs to be on the other side of the battery, with everybody else connected to those people, making a big circle to complete our circuit. What about the light bulb? Where should they be going?
They can go anywhere in the circuits as long as there is a wire on both sides of them.
Alright, good. So let me have everybody come up to the front. And let's make our big circuit. So now that our circuit is complete, we can start the flow of electrons. And then as this flow is going, what sign should the light bulb be holding up?
It should be on light on.
Yeah, good job. Alright, so now my partner is going to come and disconnect one of our wires. Alright, so you guys disconnect. And so now what happens to our flow of electricity?
It stopped.
Alright, so why did it stop?
Because the circuit is incomplete.
Yeah, so since our circuit got broken, you can't pass your washer to the next person, and so you can't accept the washer from the person before you because you already have one. So therefore, it stops the flow of electricity. So when our circuit is broken, electricity stops. Alright? So let's go ahead and reconnect our circuit, but now, me and my partner are going to act as a bigger battery, so we're going to be passing these really fast, so you have to keep up. Okay? So here we go. Alright, so we do this until everybody gets kind of tired and hot. Alright, so, whew, that made me really tired. Is everybody else feeling pretty tired now?
Exhausted.
Yeah, so as we move these faster, you guys seem to be expelling more energy. So since we're pretty tired, let's all go have a seat and let's talk about what we were doing. Okay, so now that everybody is back at your tables, I want you to look back at your vocabulary worksheet, which is also our electricity and its travels worksheet. So we are going to be passing out some materials for you. So can I get the materials manager to come and pick up a bag of materials? Your bag of materials will have a battery with 2 wires, and it will have a light bulb. Alright, so each group will have 2 sets of materials because each pair gets 1 set of materials each. So the first thing you're going to do is reconstruct the circuit that we just made as a class in circuit theater using the materials in your baggies, with the goal of being able to light the light bulb. You may need to use the paper towel roll in order to see that your light is being turned on because they are kind of dim. Alright, so go ahead and begin with that. So what is the first thing that you do when you are building a circuit?
First, we attach a wire to one end of the battery.
Okay, and then what comes after you attach the wire to the battery?
Next, we attach a wire to one side of the light bulbs.
Yeah, and then what's the final step to complete our circuit?
We attach another wire to the other side of the light bulbs, and then the open side of the wire to the open side of the battery.
Alright, good. So now that everybody seems to have completed their circuit with a working light bulb, let's look at number 1 on your electricity and it travels worksheet. So the 2 broken circles on your worksheet are actually representing the wire. So if we look here, so these are our broken circles, and so this is the one wire right here. Alright, so it's made really big because so you can draw the electrons and your wire. So you'll be placing the light bulb, the battery, and the electrons in your circuit. Use the circuit you just made as a reference. You're also going to be describing what is happening in the circuit while listing out all the different types of energies that are present. So a system is one of our vocabulary words, and it is a set of interacting parts that work together and form a whole. So everybody say system with me.
System.
Yeah. So, great. So now that we know what a system is, go ahead and do number 1 on your worksheet using your ink pad and the eraser of your pencil to make the dots representing your electrons. Don't forget your arrows for your electrons so we know which direction the electrons are flowing. Alright, so now for number 2, you should take something out of your circuit and write on your worksheet what you took out. It literally can be anything. It can be the light bulb, it can be the battery, it can be the wires, whatever you want. So in the same way as it was done for number 1, draw out your circuit now for number 2 and explain why it isn't working and what energies are present now that something was removed. Alright, so what item did you remove?
The battery.
Okay. And so when the battery was removed, what do you think happened to the flow of the electrons in the circuit? How do you know?
The electrons stop because the light isn't on anymore.
Alright. So for the second part of our circuit theater, everyone said that they were pretty hot after you were passing the beams really fast. So raise your hand if you think this was an accurate description of what really happened to the wires and other things in circuits when there are a lot of electrons passing through them. Alright, for those of you with your hands raised, why do you think this was accurate?
Because the light bulbs get hot because the light bulbs get hot when they have been on for a while.
Okay, and what about those that disagree? Why is that not accurate?
Because I filled my circuits earlier and it wasn't hot.
Okay, those are some pretty good reasons. So when you have a completed circuit, its parts are actually releasing heat energy from the electrons flowing through them. As electrons are moving through the circuit, they are carrying a certain amount of kinetic energy. So what is kinetic energy?
What moving things are.
Okay, so yeah, so moving things have kinetic energy. Alright, so we're going to post the definition for kinetic energy, which is up there. Alright, so kinetic energy is the energy of motion. So whenever you run or walk, you have kinetic energy. Since the electrons are flowing through our circuit, they have kinetic energy. So what happens to the kinetic energy of the electrons in the circuit if the circuit is broken and the flow of electrons stops?
There's no more kinetic energy.
Yeah, so the electron's kinetic energy is transformed into potential energy. So potential energy is our next definition. And potential energy is the energy stored in a body or system. Everybody say potential energy with me.
Potential energy.
Yeah. All right. So be sure you're filling in these definitions on your vocabulary worksheet. And so one of the laws of physics states that energy is never created nor destroyed. So when the electrons stop flowing, there is potential energy built up. So let's think back to everyone getting hot during the second circuit theater. Why was everybody getting hot?
We were moving a lot.
Exactly. Because you were moving a lot, you were getting hot and giving off a lot of heat energy. But what is heat energy? Heat energy is a form of energy that transfers between substances through kinetic energy. So this is our last definition. So find this on your worksheet and fill in the blank. Alright, so because you had a lot of kinetic energy passing the electrons from person to person, you built up a lot of heat energy. This is the same reason that circuits get hot. When they have a lot of electrons passing through them, they build up heat energy. Alright, so go ahead and look at number 3 and number 4 on your worksheet, and we are going to do those right now. Alright, so now that we've gone over what is going on in a complete circuit when it is producing electricity, and we have gone over the energies present in the system, y'all are going to be employees of our very own Fix-It shop. Alright, so I'm going to be passing around our Fix-It shop worksheets, which look like this. Alright, so what we need to do as employees is, in your pairs and using your circuit materials from earlier, fix some broken circuits that customers brought in. Alright, and then the diagrams for the broken circuits that the customers brought in are on the worksheet, labeled as circuit number 1, and then on the back is circuit number 2 and circuit number 3. Alright, so you will be getting the diagram of the circuit that the customer brought us, and it is your job to determine what is wrong with the circuit any way that you can. When you figure out what's wrong with the circuit, you will be writing up a work order for the customer describing what is wrong in the words, using the words electricity, energy, and electrons, and you'll be describing how to fix it. Alright, so each person needs to write up their own work order, but you can work with your partner to figure out what is wrong with the circuit. Each pair will be doing all 3 of the circuits. Alright? So what are some ways you can figure out how to fix the circuit?
We could use our material from before to reconstruct the circuit.
Yeah. So what's a good sign that the circuit is or is not working?
If the light on, the circuit is working, and if it's not, then the circuit is not working.
Great. So now that everybody has your materials, you may begin fixing those circuits. And we'll be walking around to help you if you get stuck on something. Alright, so let's look back at number 1 on our worksheet, electricity and its travels. So I'm going to pick a random person, and when I pick on you, I want you to tell me where to put the part of the circuit that I asked for. Alright? So, how about you? Where did you end up putting the battery in your circuit?
I put it in the open space on the right of the diagram.
Okay. And which direction was the positive side of the battery facing?
It was facing up.
Alright. So someone else tell me where to put the light bulb in the diagram. Alright, so where did you place the light bulb in your circuit?
I put it at the top opening in the diagram.
Alright, good. And finally, I need somebody to tell me where the electrons go and in which direction they are flowing. So where do the electrons go in the diagram, and which direction are they flowing?
They are in the wires, and they're going around the circuits from the negative side of the battery to the positive side.
Very good. So yeah, in a circuit, the electrons always flow from negative to positive. I'm going to show you a quick video demonstrating the flow of particles in a circuit. Alright, and as I show this video, I'm going to ask you some questions. Alright, so what are the electrons doing as the switch is flipped on?
The electrons are flowing and the light is on.
Okay. And what happens when the switch is flipped off?
The electrons stop flowing and the light goes off.
Okay, good job. So when the switch is off in the video, it is like what we did for number 2, where you remove something from your circuit. So what happened when you remove part of your circuit?
The circuit didn't work anymore.
Exactly. So yeah, like in the video, when the light went off, the switch was off. When you remove something from your circuit, it no longer worked. Looking at number 3, let's talk about the types of energies in your circuit. So what are some energies that were in your circuit?
Kinetic energy, potential energy, heat energy, light energy, electricity.
Okay, so yeah, those are some good examples, except for that last one. Electricity actually isn't an energy. Electricity is just the measure of energy in the system. Alright, so number 4 on your worksheet asks you to label the 2 energies that the system gives off while the circuit is complete. What are the energies that the circuit gives off when it is closed?
It gives off heat energy because the electrons are flowing through the wires and the light bulbs, and they get hot because of that. It is also giving off light energy because the light bulbs is lighting up.
Awesome. So yeah, when the circuit is complete, the wires in the light bulb get hot because they have electrons flowing through them, and the electrons have kinetic energy, which is the energy of movement, causing electrons to give off heat. So we are going to pass around some clothes hangers to each table in order to better see, or should I say feel, the movement of particles creating heat. Alright? So the first thing you're going to do is feel the clothes hanger and make note of its temperature before you do anything to it. Alright? So now I want one person in your group to take the clothes hanger and bend it back and forth 5 or 6 times really fast. Alright? So now quickly feel the hanger in the spot it was bending. What does it feel like now? Did it get hotter or colder?
It is hotter.
Exactly. So the clothes hangers get hot after you bend it a few times. This is because as you bend it, the particles in the clothes hanger are moving past each other, causing friction. This friction caused energy to be released in the form of heat energy. This is the same as a circuit, in that particles are flowing through the circuit, moving past each other, causing friction and releasing heat. Alright, turn your hangers back in, and let's look back at our fix-it-shop work orders. Alright, so looking back at our fix-it-shop work orders that you filled out as employees at the fix-it shop, what was wrong with number 1?
The circuit wasn't complete at the light bulbs.
Okay, yeah, so the circuit wasn't completed at the light bulb. Therefore, the flow of electricity wasn't happening. Alright? So, what was wrong with circuit number 2?
The light bulb didn't work.
Alright, good. And what about circuit number 3?
The wire were attached to the same side of the battery.
Awesome, you guys are so good at that.
Since everyone has now fixed a few circuits that didn't work, and you are all experienced fix-it-shop worker, we are going to look at some more complex circuits. For the first circuits, we have here the light bulbs that doesn't seem to be working. So as a class, let's build the circuits and see what's wrong. What is the first thing we need to do in order to build a circuit?
We need to connect our 2 batteries together at the positive ends.
Good job. What's come next?
Attach the wires to the other ends.
Where does our light bulbs go?
It goes at the ends of the open wires to complete our circuit.
Great. Now that we have our circuit built, we can see that it really doesn't work. Talk to your shoulder partner for a couple of minutes and come up with an answer to the following question. Make sure in your answer you include an explanation of what is happening to the electron in the circuits. The question is, why does this circuit does not work?
Alright, so the answer is the circuit does not work because the batteries have to be lined up in the same direction in order for electrons to flow.
Yes, the reason the circuit doesn't work is because the electrons aren't able to flow. Since the electron flow from the negative to the positive, both batteries are giving off electrons toward the other battery negative ends, which would cause there to be a stop in the flow. Let's build this second circuit. So, this circuit is kind of like the one we saw earlier in the video, except it has an extra battery. Once again, talk to your shoulder partner in order to come up with a reason that the circuit is not working. How come the circuit isn't working?
The switch is in the off position.
Y'all are all so smart. The reason the circuit isn't working is because the switch is in the off position, causing there to be a break in the circuit, stopping the flow of electron. If I were to flip the switch to the on position, the circuits work and the electrons are flowing, causing the circuit to give off lights and heat energy. Now it is time to put your newfound knowledge to the test, and you're going to show us what you know about our exciting electricity experiment we did today. And if you have extra time, we're going to have an extra journal prompt, which is, what ways can you help conserve energy or electricity in your home?